Most students learn modulus incorrectly. They memorize cases, they panic in the exam, and today I'm going to show you that modulus is nothing more than distance. Once you understand that, every modulus question becomes easier. Before we solve a single modulus question, before we touch inequalities, or before we do any exam questions, I want to fix one misconception that causes the students to lose marks. Most students think modulus means you make everything positive. Like, modulus of x, if you open it up, you get plus and minus x. That's not wrong, but it's not the actual definition. So, modulus of 5, let's say, for example, is equal to 5, and modulus of negative 5 is also equal to 5. That's right. Now, look at these two numbers. 5 gives 5, negative 5 also gives 5. Why? Because modulus measures distance. So modulus is simply distance from 0. Now, if I will have something like modulus of x, I will automatically look at it like the distance of x from 0, because modulus of x is same as modulus of x minus 0, right? So it is all the variables that are at a distance of 0 on a number line in one dimension. Okay, now let's say you have this number line. Here is 0, now here is 5, and here is minus 5. Now let's look at this number line. How far is positive 5 from 0? What is this distance? This distance is actually, so this, we will say this is modulus of 5, the distance of 5 from which comes out to be 5, and this distance from 0 to minus 5 is also 5. It doesn't care whether it is minus 5 or positive 5. The distance is an absolute value in positive, right? So notice something interesting here. The direction changed. 5 was on the right, negative 5 was on the left, but the distance stayed exactly the same. So modulus of x does not care whether you are left of 0 or right of 0. It only cares about how far away you are from 0. Okay, so this is the big idea. So if this is 3 or this is minus 3, this distance is going to be modulus of negative 3, that is 3, and this distance is also going to be modulus of 3, that is 3. Okay, and that's exactly the reason why modulus can never be negative. So modulus of 7 will always be 7. Modulus of negative 7 will be 7. Modulus of 100 or 10,000 will be 100 or 10,000. And modulus of negative 100 or negative 1,000 will also be negative 100 or negative 1,000. Now, the common mistakes that students make is that you guys memorize these examples, which is a dangerous thing, but you don't understand the actual meaning. And then the moment Cambridge gives something like, for example, modulus of x minus 3, right? So you'll start to panic because you stop thinking about the distance. Now, what does this modulus of x minus 3 mean? Now, this expression does not mean distance from 0, not from 0. It means distance from 3. So if you are in a single dimension plane, right? So this is 0, this is 1, this is 2, this is 3. Now our new origin is going to be this 3. So now we don't know what this modulus of x minus 3 is equal to. Let's say if I say 2. Now I'm going to find out the variable or the number that is 2 units from 3. So this is going to be 5. This is 2 units, right? And this is going to be 1 as well, right? Because this is 2 and this is 2, and both are modulus of x minus 3 equal to 2 and modulus of x minus 3 equal to 2. I hope you are understanding it till here. Now, this single idea is enough to solve almost every modulus question you'll ever see. And we'll see why. So suppose Cambridge asks us to solve modulus of x minus 3 equal to 5. Now I will be teaching you a lot in this very video only, a lot of ways that you can do it by opening the bracket and giving it a plus and minus and then checking it on the graph. I will also be teaching you squaring both the sides and everything. However, what I don't want you to do is that you only memorize the cases. I don't want you to memorize anything. I want you to think which numbers, in this case, which numbers are exactly 5 units away from 3. So if this is 3, then 8 is going to be 5 units away, and negative 2 is going to be 5 units away. So the answer to this question, and we will explore it later, if I square both the sides, because squaring only retains the positive number, so this gives me x square minus 6x plus 9 minus 25 equal to 0. So x square minus 6x minus 16 equal to 0. X square minus, so 8 2s are minus 8x plus 2x minus 16 equal to 0. This gives me x minus 8 and x plus 2 equal to 0. And you can see that our answers are minus 2 and 8. Now, we will find it out in a bit. Now, let's use the idea we learned earlier. So remember, modulus means distance. It does not mean brackets. It does not mean cases. And it just means distance. Now, if I say that modulus of x is equal to 4, so what I'm actually saying is that the distance of x from 0 is equal to 4. So on a number line, which units are which numbers are 4 units away from 0? So it is positive 4 and it is negative 4. This distance is 4 and this distance is 4. Simple. Now, so we can write down the answer as x is equal to 4 and x is equal to negative 4, or like this, x is equal to plus and minus 4. Now, why two answers? Notice something, that the distance did not tell us direction, right? It tells us the absolute value. It only tells us how far. That's why modulus equations usually produce two answers. We will come to the cases where it may not be the case every time. So modulus of x is equal to 7. If I ask you quickly, you will produce me the answer that x is going to be equal to plus and minus 7. And this is the reason why we do it. Now, let's move beyond 0. What I mean by that is, let's move beyond the 0. So what if we have x minus 3 is equal to 7? So now we are asking for the numbers which are 7 units away from 3. So it is going to be 3 plus 7 and 3 minus 7, right? So on a number line, if this is 3, so 7 units here, which is 10, and 7 units here, which is going to be negative 4. Okay. Now, similarly, if you have, like the previous equation that we did earlier in this video only, x minus 3 is equal to 5. So x is going to be equal to 3 plus 5, that is 8. And x is going to be equal to 3 minus 5, that is going to be 3 minus 5, that is going to be negative 2. Now, what if you had x plus 3 equal to 5? X plus 3 equal to 5 means that the distance of x from negative 3, okay? So this negative sign shows that the difference of these two values, right? So the distance, the absolute distance between x and minus 3 is equal to 5. Now you will do, so if this is minus 3 and this is 5, and this distance is 5 and this distance is 5, now our answer is going to be reversed. So this, instead of negative 2, we have a positive 2, and instead of positive 8, we have a negative 8, okay? Now, we and all these answers we can quickly check as well. So if I put 8 here, so 8 minus 3 is 5, modulus of 5 is 5. If I put negative 2, so negative 2, negative 3 is negative 5. Modulus of negative 5 is just 5 by definition. And similarly, if you put these answers into this equation, you will see, and you can pause the video and check quickly, you can see that it is valid. So what is the pattern that we are observing is that if we have x minus a is equal to b, then our answer is going to be a plus b and a minus b, okay? Right? So whenever you see this structure, don't memorize cases that, oh, okay, so I have to square both the sides or something else. Just understand that it is asking us to find the values of x which are b units away from a. Okay, so now quick challenge. If I ask you, if I give you this, x minus 10 is equal to 3. So without doing any algebra, tell me the answers. So x is equal to 13 and x is equal to 7. Very quick. 3 units to the right and 3 units to the left. Done. Now, in the next section, so far we have looked at simple modulus equations, but Cambridge, of course, doesn't stop there. It may give you 1 marker or 2 marker for such equations just as a starter. But what happens when the modulus contains an expression like modulus of 2x minus 1 is equal to 7? So what are the numbers twice of which quantity is at a distance of 7 from, so twice of which is at a distance, is at a distance of 7 from 1? Can we still use distance? Absolutely. Let's see how. Now, this is where many students think modulus suddenly become difficult, because now we are asking of what is a number twice of which is at a distance of 7 from 1. Now, students usually think that this has now become difficult, but it doesn't. The idea is still exactly the same, which is distance. Now, most students will immediately write this is going to be 2x minus 1 equal to 7, equation 1, and 2x minus 1 equal to negative 7, and you find two values of x. You find x is equal to 4 from here, and you find x is equal to negative 3 from here. Now, this method works, but if you don't understand why it works, you'll get lost later in inequality. So let's think first. So we have 2x minus 1, right? So let's circle it. This expression is being measured by modulus. The question is asking, when is the distance of 2x minus 1 from 0 equal to 7? So maybe this highlighted part, maybe this thing, I can rewrite it as 2x minus 1, the distance of this from 0 equal to 7. So that's the reason you write down that, okay, so 2x minus 1, therefore 2x minus 1 equal to 7. So basically what you're doing is, this is, so the variable is 2x minus 1, and I can also substitute a for this, right? So I'm saying that the value of a, therefore, so 0, and this is 7, and this is 7, so from 0, 7 units away on the right is positive 7, and 7 units away on the left is negative 7. So we are saying that this variable 2x minus 1 is equal to 7, or 2x minus 1 is equal to negative 7. And then you further simplify it in order to obtain x is equal to 4 and x is equal to negative 3. That's the reason you do it, right? Algebraically, what I could also do was 2x minus 1 is equal to 7. I could take 2 common, so I will have x minus half equal to 7. And now modulus of a times b by some theorem and theory which we are not getting into is same as modulus of a times modulus of b. So I can also rewrite it as modulus of 2 times modulus of x minus half equal to 7, and modulus of 2 is just 2, so I can divide both the sides by 2, so I will get 7 upon 2 is equal to modulus of x minus half. Now very easily I can see that we are asking for the two numbers x which are 7 upon 2 units away from half. So if this is half and this is 7 upon 2, then of course this is going to be 4, and if this is 7 upon 2, then of course this is going to be half minus 7 upon 2 is going to be negative 3. Okay, now now let's do, and whenever you find the answers 4 and negative 3, always plug them back. Okay, so put 4 here, 4 times 2 is 8, 8 minus 1 is 7, modulus of 7 is 7. Put negative 3 here, negative 6 minus 1 is negative 7, negative 7 modulus is positive 7. So yeah, this is verified. Okay, now so if you build the general idea that if you had 2x minus 1 modulus is equal to, what was it, 7, then you can substitute it by a and say that modulus of a is equal to 7, and you will say that a is equal to plus and minus 7, and then you will substitute back 2x minus 1. So 2x minus 1 is equal to plus and minus 7. Okay, now let's do one more example. Suppose you had, and I want you to pause the video and solve it for me, and then find and then try to match your answer. Let's say that thrice of a quantity is 11 units away from negative 2. Negative 2. Why do I say that? Because 3x minus 2, right? So again, you do the same thing. You write it down as the distance of 3x plus 2 from 0 is 11. Okay, so you will do from 0, so this is 0, this is minus 11, this is plus 11, and you will say that this quantity is 3x plus 2, and this quantity is also 3x plus 2. So you will say 3x plus 2 is equal to 11, which gives you x is equal to 3, and you will say that 3x plus 2 is equal to negative 11, so x is going to be equal to negative 13 upon 3. Or you could do it through the method that I did, that you take 3 common out and then you do it in the same manner. You are going to have the same answers. Notice how the modulus part took only 1 second. The rest was just ordinary algebra. The students who struggle with modulus think there are lots of different formulas. The students who score highly see the same idea every time. So distance is equal to positive number. Okay, always. So modulus of a is equal to k is a is equal to plus and minus k. That's the entire reason the method works. Now, equations are actually the easy part. The real challenge begins when Cambridge changes the equal sign to, so you earlier we were doing 2x minus 1 is equal to 7 modulus of that. What if it was 2x minus 1 is actually greater than 7? The distance of twice the variable from 1 is greater than 7, right? What happens now? This is where distance becomes even more important than algebra. Let's look at modulus inequalities now.